Unit 7, question number 2. So question number 2 wants us to evaluate an exponential function, okay? So you guys know that the general form for an exponential function is y equal a parentheses r to the exponent t, all right? Where a represents the initial, r represents the rate, and t is the time, okay? So what we're going to do for our problem is that we're going to set up a form y equals some initial value parentheses some rate over some period of time, okay? So the first thing we're going to try, so let's read the problem. So it says 3,600 is placed into an account with an annual interest rate of 9%. How much will be in the account after 25 years, okay? So when you're doing this, guys, we can see that the 3,600 is what we started the account with. That's going to be your initial. So 3,600. Now we're going to figure out time. So it says after 25 years. So again, this is the initial, all right? And it says after 25 years. That 25 is the time, okay? Now we need to calculate our rate, okay? So to calculate our rate, we're always going to start with 100%, okay? Because we're getting interest, anytime you're getting interest, that means you're going to be adding. So I'm going to be adding that 9%, and I will get 109%. However, I do not want a percentage, so I'm going to pretend that there's a decimal point right here, and I'm going to move it 2 times to the left. So 109% is the same as 1.09. And that is what goes inside of the parentheses. All right. So let's go ahead and let's calculate. So let's calculate. All right. So when you put this in your calculator, you'll get 31,043.090. Always write at least 3 numbers after the decimal point. Okay. Now we're going to round. So it says round to the nearest cent. When you're doing nearest cent, you look at the third number after the decimal point. If that number is 5 or larger, the number to the left will go up by 1 point. Because it is not 5 or larger, my answer is 31,043.09. So everything in front of what I underlined. So again, this is my answer. Okay? So let's try to do the next one. So again, guys, we know that the general form for an exponential function is y equal a parentheses r to the exponent t. Okay? So we're going to set up a form y equals some initial value, some rate over some period of time. So the question says a new car is purchased for $17,000. The value of the car depreciates at 12.25% per year. What will be the value of the car to the nearest cent after 14 years of ownership? So this 17,000 is what we bought the car for. That's going to be your initial, okay? So again, this is my initial, okay? That's what I started with. Now we're going to try to figure out time, because time is the next easiest thing to figure out. So it says after 14 years, that 14 represents time because it's the number of years. Now we're going to calculate the rate. So we always start with 100% because we're depreciating. Depreciate sounds like decrease. So that means you're going to subtract, okay? So you can use this method also. I'll show you how to use this method also, okay? So we're going to subtract 12.25%. And then I would get, so 100 minus 12.25 will give me 87.75, okay? So this will give me 87.75%. However, I don't want a percentage, I need a decimal. So this decimal point that's already here, I'm going to move 2 times to the left. So this will now become 0.8775. And that's what goes inside of the parentheses, okay? Now I'm going to put this in my calculator. So let's put from here to here. So again, from 17,000 all the way to the 14, that's what you're putting. All right, so I end up getting 2,728.403, which makes sense because we were depreciating, we were decreasing. Now we need to round to the nearest cent. Nearest cent, you look at the third number after the decimal point. If that number is 5 or larger, the number to the left will go up by 1 point. Because it's not 5 or larger, everything in front of what I underlined is my answer. So my answer is everything in front of what I underlined, which was 2,728.40. That is my result. All right. So good luck, guys. Good luck.